In section 4.7, we're going to be talking about the quadratic formula and mainly how to solve quadratics using this formula. To solve a quadratic equation in standard form, ax squared plus bx plus c equals 0, we can use the quadratic formula to find our x-intercepts. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's kind of a long process, but as long as you just know where to put your a, b, and c values, you'll be good to go. And then again, just as a reminder, the quadratic formula finds zeros on a graph. So whatever x values we get, we can imagine that that's where this parabola is going to cross over on the x-axis. So let's look at this as an example problem and see how we would use the quadratic formula to solve. Here I have 2x squared minus x equals 4. So in these problems, unlike with completing the square, I'm going to want to get everything to the same side to solve it. So I'm going to subtract the 4 on both sides, and I'm going to be left with 2x squared minus x minus 4 equals 0. I want to do that because now I can easily see what my a, b, and c values are. My a value is 2. My b value is negative 1, and my c value is negative 4. I would always recommend writing this down because that'll help when you're plugging this stuff into this big formula. From here, using the quadratic formula, I'm going to do negative b, so it's going to be negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times negative 4, and all that's going to go over 2a, so 2 times 2. So from here, I can simplify this a little bit. Negative of negative 1 is positive 1, plus or minus everything in that square root is 1, and then minus 4 times 2 times negative 4, that's going to come out to be 33, all over 4. So from here, I have my two x values in simplest radical form. X equals 1 plus or minus square root of 33 over 4. You could leave it this way if you want to, but if it helps you see that there's two solutions, you could also write it like this. Or like this. And you're done. So now let's look at another example. We have x squared plus 6x plus 9 equals 0. And again, we're going to want to solve for x using the quadratic formula. So again, for here, I'm going to identify my a, b, and c values. Everything's already to one side, so I'm good to go there. My a value is 1. My b value is 6. And my c value is 9. As I'm plugging this stuff in, I'm going to do negative b, so negative 6, plus or minus 6 squared minus 4 times 1 times 9. And I'm going to take that all over 2 times 1. When I do this, everything inside the square root, this is going to end up being 6 squared is 36, 4 times 9 is also 36. So it's going to be left in the square root is 0. So I'm going to have negative 6 plus or minus the square root of 0 over 2, which is just 0. Negative 6 plus or minus 0 is the same thing. So I just have negative 6 over 2, and x equals negative 3. When everything in our square root would come out to be 0, this is going to be an example of an equation that only has one x-intercept. So it would be a graph that kind of looks like... it would be a graph that kind of looks like this. So you have your axis, it only touches the x-axis at one point. One way we could see how this is going on before even really going through the whole quadratic formula is to focus on the discriminant. So what the discriminant is, looking at the quadratic formula, the discriminant is this part right here, b squared minus 4ac. If we focus on the discriminant and if we see what type of value we're going to get under the square root, that's going to help us see what type of graph we're dealing with and how many solutions we're going to get. So if the discriminant value is positive, like our first example, you would have two solutions, like a positive or a negative root, and if we graphed it, it might look something like that, where the parabola is crossing over the x-axis 2 separate times. If our discriminant value is 0, like in that last problem that we just did, you're always only going to have one solution, and this graph would only touch the x-axis at one point. What we didn't look at, and what you might come across, is if our discriminant is negative. In this situation, we would have no real solutions. This would be an example of a graph like a parabola that you see here that doesn't touch the x-axis at all. We'd have no real solutions because you can't take a square root of a negative number. You can get an imaginary answer, which we'll get into in the next unit.